All right, now I want to do some examples of multiplying and dividing rational expressions with more than one variable involved. So in this first example, 25a over 9b to the 8th times 3b to the 5th over 5a squared. Okay, so again, we can multiply straight across. I want to just automatically start looking at the factors, right? Because we're already multiplying everywhere, right? There's no addition or subtraction involved. So I'm noticing that 25 over 5 is 5, for instance. Okay, so I can make that cancellation. And then 3 over 9 is 1/3. Yes. Okay, and then we have a over a squared, so I have one of them upstairs and two of them downstairs, so one of them will remain downstairs. And then b to the 5th in the numerator and b to the 8th in the denominator. So the ones up top go away, and how many do we have left down here? Well, 3 of them, right? If we cancel out 5 in the numerator and denominator, we'll have 3 b's left downstairs. Okay, so now let's see if I can clean all that up. So we've got 5 in the numerator, and that's it, right? Everything else canceled out. And then in the denominator, we're going to have 3b cubed a. Okay. Now, in the original expression, we had b to the 8th and a squared initially, and now we have b cubed and a. Because both b and a existed as factors of the original expression, and they still exist as factors of the denominator in the final expression, we don't have any hidden domain restrictions. Okay. All right, so now let's look at this example of x over 5y divided by x over 10y squared. All right, so I'm going to write that as x over 5y times the reciprocal of the divisor, right, which is 10y squared over x. Okay, now that we have the multiplication, this becomes very easy, right? So I'm going to cancel out the x's. What else goes away? 10 over 5 is 2, right? And y squared over y is just y, right? We just have one y. Okay, so what's left here? In the numerator, I have 2 and I have a y left, right? And in the denominator, nothing at all, right? It all canceled out. So we have 2y, and what did we cancel out? We canceled out x entirely, right? But we want to say x can't be 0, and y can't be 0 either, right? Because both x and y initially, in that initial expression, were in denominators, right? So we have to be aware of that and make sure we list those as restrictions. Let's look at this next example of y squared over y squared r squared plus 4ry times y squared r squared plus yr minus 12, all divided by y. Okay, so we've got a little bit of factoring to do. So we're multiplying here. I know I can cancel out a y right off the bat, but I'm going to leave it alone for just a minute. Okay, so I want to look at this first denominator of y squared r squared plus 4ry. Okay, so r and y are both common to both of those terms. It's the greatest common factor, so I could have ry times yr plus 4, right? If I factor out a yr from both of those terms. That's what I'm left with. Okay, now the denominator, let's not lose the denominator there. The other denominator is y. Okay, so I've got our denominator taken care of. Look at the numerator there, the y squared r squared plus yr minus 12. Okay, so you see kind of a squared term and then one that's not squared and then a constant. It kind of reminds you of x squared plus x minus 12, right? But you've got all these other variables in there. Okay, So what I would do is think about that y squared r squared as like an x squared, right? And if we're factoring this, I mean, this is what I see in it. So you've got a yr and a yr. You want factors of 12 that add to 1, right? You think about that yr as like your x term. So factors of negative 12 that add to 1, and I would say positive 4 and negative 3. Does that work? So in the middle, I'm going to have negative 3yr plus 4yr, which is yr, okay? So you can FOIL that out if it helps you, but that's essentially what we have. Okay, so yr plus 4 goes away, doesn't it? Yeah? And so we're left with y squared times yr minus 3 divided by y squared r, right? I've got y times y down there. So this factor of y squared also goes away. So we end up with yr minus 3 divided by r. And no, you cannot cancel the r's and have y minus 3. That doesn't happen because we're subtracting in the numerator there. So, but we need to list the domain restriction. So we end up with a simplified version of yr minus 3 divided by r. But then what did we cancel? So off on the side here, I'm thinking, okay, yr plus 4, what makes that 0? So I'd say the product of y and r can't be negative 4, but I can't say a whole lot more about it than that, right? And I know that y also can't be 0 because we canceled that factor of y squared out as well. So those are the two restrictions that we'll have. So in this last example, we have 20t cubed y cubed divided by t minus 5y divided by 4t y squared divided by 5ty minus 25ty squared. Okay, so the first thing I want to do with a problem like this, multiply by the reciprocal. So I'm going to have 20t cubed times y squared divided by t minus 5y, and I'm going to multiply that by 5t squared y minus 25ty squared divided by 4t y squared. Okay, so now that we've multiplied by the reciprocal, let's try to do a little bit of factoring. Okay, so we had 20 t cubed y squared divided by t minus 5y. Okay, now there's not a whole lot of factoring to do in the denominators, right? 4ty squared here. We're going to be able to cancel some things with the numerators, but I want to look at that second numerator there, the 5t squared y minus 25ty squared. What can I factor out of that? Okay, so on the onset, I'm like, well, there's a difference there, but it's not the difference of squares, right? But what's the greatest common factor? I've got 5 and 25, so 5 is something I can pull out. I've got t squared and t, so t I can pull out. And I've got y and y squared, so I can pull out a y. Okay, so what's left? If I pull out a 5ty, I'm going to end up with t minus 5y when I'm done. Okay? Yes. All right. So now t minus 5y, that can go away, right? I almost want to clean this up a little bit. I know I can cancel some more stuff, but let's see what I have. I really have 20 times 5 is 100, right? So I have 100, and t cubed times t is t to the 4th. And y squared times y is y cubed. Just cleaning up that numerator, what we have left there. Divided by 4t y squared. Okay, so 100 divided by 4 is 25. T to the 4th divided by t is t cubed. And y cubed divided by y squared is just y, right? So 2 y's downstairs and 3 upstairs. So we have 1 left. Okay, so we end up with 25 t cubed y. That's kind of fun. But then what are the domain restrictions? T and y were both factors down there, so I'd say t can't be 0. y can't be 0. We canceled out a t minus 5y. Okay, so again, we can't get a specific value of what t and y can't be in that case, but we do know that t can't be 5y, right? Because if t were equal to 5y, we would have 0 there. Okay, so even with more variables involved, the factoring process is essentially the same. It looks strange, it feels a little bit weird, but it's really no different than if we just had one variable.